Hi, everybody. In this video, I'm going to go through some of the relevant theorems and postulates we're going to be using throughout our work with parallel lines and transversals. So the first thing we are going to do is we are going to have that it is given these two parallel lines, L and M. So these are both parallel lines. Here's L and here's M. And we also have this transversal creating 8 angles. So 1, 2, 3, 4, 5, 6, 7, and 8. So it is given that L is parallel to M, and we have transversal T intersecting those two lines. Okay, so the first important thing we need and we're going to be using is the corresponding angles postulate. And this is a postulate, so we are then assuming that this is true. And again, this will be used to prove the other theorems. So this states if two parallel lines are cut by a transversal, then corresponding angles are congruent. Corresponding angles are congruent. And we talked about what these corresponding angles were. They're in the same kind of position. They match up with each other. So using the corresponding angles postulate, I can say angle 1 is congruent to angle 5. I can say angle 2 is congruent to angle 6, since they are corresponding. Angle 3 is congruent to angle 7. And angle 4 is then congruent to angle 8. So this is assumed to be true and will be used or is used to prove the following 3 theorems. So I'm going to write theorems below because we're going to write them below this. So what are these theorems? First is the alternate interior angle theorem. Alternate interior angles theorem. And that states when two lines are cut by a transversal, or if two lines are cut by a transversal, alternate in, oh, I knew I was missing something. When two parallel lines are cut by a transversal. Not just any two lines. Okay, so if two parallel lines are cut by a transversal, then alternate interior angles are congruent. So looking at our diagram up above, these two lines are parallel. We have this intersecting line, so I can now conclude that my alternate interior angles, 3 and 6 are congruent. And also, and this shouldn't have been drawn so poorly, angles 4 and 5. Angles 4 and 5, the other pair. And really, these are congruent, right? That's what the theorem states. They are congruent. And the proof of this is in the OMHS, so please read through this to see how it is proved. The next proof is the alternate exterior angle theorem. I bet you can guess the beginning, and I'm going to get it right this time. If two parallel lines are cut by a transversal, because that's what we are given here. If two parallel lines are cut by transversal, then the alternate exterior angles are congruent. So what are the alternate exterior angles again? Those are the angles that are outside of our two parallel lines and alternate or opposite sides of the transversal. So angle 2 and angle 7 here are alternate exterior angles. So angle 2 then is congruent to angle 7. Also, the other pair would be angle 1 and angle 8. Angle 1 and angle 8. And since, again, they are exterior angles, when we have these two parallel lines cut by a transversal, angle 1 and angle 8 here, these alternate exterior angles are congruent. The last proof, and this proof is also in the OMHS, as well as this last proof for, the same side interior angle theorem. All right. If two parallel lines are cut by a transversal, the same side interior angles, and I'm just going to write same side interior angles are supplementary. And this one's an important one. So here we are looking at those same side interior angles. So angle 4 and 6 are same side interior angles. As are 3 and 5. So this is stating that these are supplementary then. So the measure of angle 3 plus the measure of angle 5 is 180 degrees. The measure of angle 4 plus the measure of angle 6 is also 180 degrees, since those are our two pairs of same side angles. So this is an important theorem that we will use as well, and please make sure you read through the proof, which is in the OMHS. All right, head to the last video now, looking at some of the examples.